Hello everyone, welcome to another video in our civil engineering refresher and review. So the featured topic for this video are simple curve and compound curve in surveying. So to recall, for a simple curve, we have here a circular horizontal curve. No? So this is about horizontal curve. So it starts with the PC, the point of curvature, and it ends at the PT, which is the point of tangency. So from PC we can draw a tangent, and also from PT we can draw a tangent. Then the tangents intersect at PI. So we have the point of intersection. Then we have here the radius of the circular curve. So we have this as R. So the radius and the tangents are 90 degrees to each other. So we have here the point O, which is the center of the circular arc. Then we have here the central angle I. And this is also I here by law of tangents of an arc of a circle. Then we have here the length of the long chord C. Then we have LC, L sub C, the length of the curve. Then we have here by property, if this is I over 2. Property of circle, that is the angle between the chord and the tangent at the point of intersection. So that is I over 2. Then we have here the external distance from the PI to the center of the curve. And we have here the middle ordinate from the center of the curve to the center of the long chord. Okay, so by trigonometry, this is I over 2 here, and then by forming or considering triangles, we can solve for the requirement na if some of the elements of the compound of the simple curve, if some of the elements of the simple curve are given, then we can solve the requirement in the problem. Sample, problem number 1. The bearing of two lines AB and BC are north 30 degrees west and north 20 degrees east respectively. A 5 degree simple curve is to connect these two lines as tangents. Compute the length of the long chord. Okay, so we have two lines, no? AB and BC. So with the bearing here, so north 30 degrees west. So if this is the north direction, so north 30 degrees west. So we have line AB, So this is point A. Then somewhere here is point B, So this is at an angle of 30 degrees. And then we have here line BC. So meaning this is point B here, then we have point C somewhere here, so lines AB and BC are tangents to a circular curve. So we have here the circular curve. Okay. So the curve started at A, which is the PC, and at C, which is the PT. Then the tangents intersect at B, which is the point of intersection. So this is 30, north 30 degrees west, then north 20 degrees east. So the angle here at the intersection is 50. So that is also the central angle of the simple curve, Okay, so this is a 5 degree curve, so we can solve for the radius R. So given by the formula, which is the arc basis, 1145.916 over D. So for a 5 degree curve, the radius is 229.18. So this is the length of the chord, So long chord, which is the question. So we have the radius R, then we have the radius R intersect at the center O of the circle, na? Okay. So R is 229.18 and then I is 50. So if we take half of this, so this is C over 2, C over 2. And this is I over 2, which is 25 degrees. So I can consider this triangle, no? C over 2, the radius, and I over 2, which is 25. So sine of I over 2 is C over 2 over R. So sine of 25 is C over 2 over R, which is 229.18. So C can be solved 193.71 meters. Problem number 2. The offset distance from PC to PT of a simple curve is 36 meters. The angle of intersection of the tangents is 24 degrees. If the stationing of the PT is 42 plus 324.52, what is the stationing of the PI? Okay. So, we have a simple curve na. So, this is the PC. This is the PT. Then, if I will draw tangent to PC, ito yan. And then, we have the offset distance na from the PC to the PT. So, that is the perpendicular distance from the tangent through the PC to the PT. So, we have here 90 degrees and this is 36. This is what we call the offset distance of the PT from the PC. Then, the angle of intersection is 24 degrees na. So, if I will draw tangent to the PT, so we have here angle 24 degrees at the PI. So, in the figure, this is 36, this is t, and this is 24. I can use the sine function. Sine of 24 is 36 over t. So, I can solve for the tangent, 88.51. Then, the question is the stationing of the PI. And the stationing of the PT is 42 plus 324.52. So, PI, we need PI, no? Okay. So, I can solve for the, this is the radius of the circle, no? So, I can solve for the radius by using the T. And this is I over 2, no? Half of that. So, this is 12. This is R. This is T. I have T. So, I can solve the R using tangent of 12 equal to T over R. So, with T equal to 88.51, I can solve for R, 416.41. And then, I can solve for the length of the curve, na? The LC. Then, after I have LC, I will subtract it to PT. I obtain PC. And then, I will add the tangent, na? Okay. So, I will continue. I have here LC. I can solve LC, na? By using LC equal to R times I. So, R is 416.41. Kindly check, na? R is 416.41. Then, I is 24. But multiply this by, convert the angle theta into, or angle I into radian, multiply by pi over 180. So, this is 174.43 meters. Okay. So, the station of the PC is station PT minus LC. So, 42 plus 150.09. So, station of the PT. Ano ba yung station sa PT dito? 42 plus 324.52. So, 324.52, you subtract 174.43. Kindly check na. Then, that is 150.09. Then, to get the station PI, so, nagkabaliktad pala, ano na lang, i-interchange na. So station PT 42 plus 3 to 4.52 minus LC 174.43. So that is station PC 42 plus 150.09. Okay. So to get station PI, so we have station PC plus T. Then I can get station PI. Okay, so that is about simple curve, na? So we have the elements, and then by using trigonometry, we can just solve the requirement. We have the compound curve. So compound curve is composed of two simple curves connected together. So we have here the green simple curve, and then we have the red simple curve. So together, they are called the compound curve. So still, we start at the PC and with the point PT, and they intersect, or they meet at the point called PCC, the point of compound curvature. PC is still the point of curvature, PT is the point of tangency, PCC is the point of compound curvature. Then we have the tangents, T1, T1. We have also the tangent T2, T2. So the T1, T2 here, the blue and the yellow together is called the common tangent of the two simple curves. Okay. So if we extend T1 and T2, they meet at the PI. Okay. Then we have the radius of the first curve R1. We have also the radius of the second curve R2. We have I1. This is also I1 here. I have I2. This is also I2 here. And this angle at the PI is I1 plus I2. Then we have the chord length C1, the chord length C2, and then we have the long chord from PC to PT, that is C. Then we have LC1, length of curve 1. Then LC2, the length of curve 2. So still, by using trigonometry, we can solve the requirement by using the given elements of the compound curve. So just take note that the compound curve is just composed of two simple curves. So we can apply our trigonometry to each of the two curves. Okay. So problem number 3. Two tangents intersect at station 3 plus 680. So this is at the PI. A compound curve to be laid on these tangents has the following data. I1 28 degrees, I2 32 degrees, degree D1 3 degrees, and degree D2 5 degrees. Compute the stationing of the PT. So we are given the station of PI 3 plus 680, the intersection. Okay. So from the I and the D, we can solve for R So R is 1145.916 D. So for R1, this is equal to 382. For R2, this is equal to 229.80. Now we substitute the degree of each curve. So 3 degrees and the 5 degrees in order to obtain the radii of the two curves. We can also solve for the length by using LC. LC equal to RI. So R is 382 times 28. So this is convert to radian, multiply by pi over 180. So 186.68. Then for the second curve, R is 229.18 times 32, multiply by pi over 180. This is 128 meters. Okay. So we can now draw the compound curve So the PI is at 3 plus 680. Then we have the two curves here. PC. So the radius of the first is 382. The second, 229.18. Then we have LC1, LC2. So the question is the stationing of the PT, no? Ito, where PI is at 3 plus 680. Okay, so this is tangent T1. This is tangent T2. This is PCC. So T1, and then I can solve for T1, So this is 28, so half is 14. So I have tangent of 14 is T1 over R1. At R1 is 382, so T1 is 95.24. I can consider also the second curve. The central angle is 32, so this is 16. So tangent 16 is T2 over R2, where R2 is 229.18. I can solve for T2. Now, I can consider this triangle here, and the common tangent is T1 plus T2, so that is 160.96. So I can consider this triangle here. So this is 28. This is 32. This is T1 plus T2. This angle is 120 na. This is 60, so the sum is 180, so this is 120. Can call this x, and T1 plus T2 is 160.96. By using sine law, I can solve for x na. So 160.96 over sine 120 equal to x over sine of 32. So x is 98.49. Then I can get the station of PC, that is Pi minus x na. So this is x, this is T1. So I can get station PC, that is station Pi minus x minus T1. So station PC is 3 plus 4, 86.28. Then I have the LC na. So LC1 and LC2. So to get the station PT, I can add na station PC plus LC1 plus LC2. So I get 3 plus 800.96. Okay, so compound curve na. Last problem for compound curve. Given a compound curve with long chord equal to 142 meters and forming angles of 12 degrees and 18 degrees with the tangents. The central angle of the first curve is 16 degrees. Determine the radius of the second curve if the first curve is a 4-degree curve. Okay, so I have here the compound curve na. Then I have the long chord, which is 142 meters. Then the long chord makes angles of 12 and 18 with respect to the tangent. So this is 12, this is 18. I can solve for the radius of the first curve, because the first curve is a 4-degree curve. So I have here the radius. So R1 equal to this. With D equal to 4. So R1 is 286.48. Then this is T1. This is T2. This is also T1. This is T2. I can have the PC, and this is the PT. This is the PCC. So chord C1 and then chord C2. So from R1 equal to 286.48, and this is central angle 16, I can solve for C1. So half of 16 is 8. So I can have sine of 8. Sine of 8 is C1 over 2 over R1. So this triangle here. So sine of 8 is C1 over 2 over R1. And C1 is 79.78. This C1. So if this is 8, this is also 8 here. And since this angle between the long chord and the tangent T1 is 12, this is 4. Na? I can consider this triangle composing of the C1, the C2, and the long chord. Na? And so, this is R2. Na? Okay. So, this is 4 degrees. C1 is 79.74. The long chord is 142. I can solve C2 by cosine law. Na? C2 square, 79.74 square plus 142 square minus twice their product, cosine ng 4. So, C2 is 62.7. I can solve also the angle theta here by sine law, no? Using this triangle again. So, sine theta over 79.74 equal to sine 4 over C2. Theta is 5.09. Okay. Now, here, since our long chord also makes angle of 18 degrees with respect to theta, theta naman. I'm sorry, na? So, so the angle here, this is I2 over 2. So, I2 over 2 is 18 minus theta. So, this is 12.91. So, this angle is 12.91. So, this is the radius R2. Okay, so C2 is 62.7. So, sine of 12.91 is C2 over 2 over R2. No? Sine 1291 is C2 over 2 over R2. So, I can solve for R2 140.32. Okay, so we have two topics for this video, na? So, simple curve and compound curve. And take note, compound curve is just two simple curves put end to end together. Okay, so thank you very much for viewing my video. And I hope my discussion helped you in your studies, na? And your preparation for your quizzes and your exam. See you next video.